We're asked to calculate the empirical formula and the molecular formula, and we're given mass percents. Percent composition is an intensive property. Calculations are much easier if we assume we have a 100-gram sample of this unknown substance. You can pick any amount if you want. You can pick 1 gram, but then you'll end up having to do 43.64% of that 1 gram, and it just gets a lot more complicated than it has to. So let's just say we have 100 grams of this compound, and then we can say the phosphorus makes up 43.64 grams. And the oxygen makes up 56.36 grams. Now the reason we got grams is because we want to convert these to moles and get the mole ratios between the phosphorus and the oxygen. Because that's one way we can interpret a chemical formula, is the ratio of the atoms in the molecule. All right, let's use the molar mass found on the periodic table to convert from grams to moles. Phosphorus has a molar mass of 30.97 grams per mole. Set up your conversion factor so the grams cancel out. And oxygen has a molar mass of 16 grams per mole. So in 100 grams of this compound, we have 1.41 moles of phosphorus. And we have 3.52 moles of oxygen. So these are the mole ratios. But unfortunately, we can't just stick decimals like 1.4 and 3.5 into formulas. So we'll have to get rid of these decimals. And one way to do that is to see how many times the smallest number goes into each of the numbers, because that guarantees to get rid of at least one decimal, because the smallest number goes into itself one time. So for the oxygen, it goes in very close to 2.5 times. At this point, all these ratios will be very close to whole numbers, either a half, a third, maybe a quarter, but it'll be pretty obvious what the factors are. So if you get 2.5 like here, you want to multiply through by 2, because then you'll get rid of that last decimal and you'll end up with the lowest whole number ratio. So your empirical formula is P2O5. So when you're at this stage, you could have multiplied by 100 or 1,000 or 1,000,000. It would just take much longer to reduce. And in the end, you'll still end up with P2O5. At this point, in order for us to get the molecular formula, we have to give you the molar mass. So the molar mass is 284. And we want to see how many times this mass, we call that the empirical formula mass, goes into the molar mass. And that'll tell us how many times to multiply the empirical formula by. All right, so phosphorus, let's just round that to 31. And there's 2 of them. So that's going to give us 62. Plus the 5 oxygens is 80. So that's going to give us 142. 142 is the empirical formula mass. What did we say the molar mass was? Molar mass is 284. So the empirical formula mass will always go into the molar mass a whole number of times, because that's what the molecular formula is, a whole number multiple of the empirical formula. So the molecular formula is 2 times the empirical formula. Not always, but in this problem. P4O10.